Welcome to Chemistry at Hononegah High School, and today we'll be looking at our third set of notes dealing with solutions, where we talk about solubility curves. Now, we talked yesterday briefly about solubility and different types of solutions, saturated, supersaturated, unsaturated. Today, what we're going to look at is how you read and interpret and the types of questions that can be asked related to solubility. Now, what you're looking at here is called a solubility curve. It's a solubility versus temperature graph that shows all the different solubilities a substance has at different temperatures. So you can actually see the amount of saturation, basically. Remember, unsaturated was when you were less than full. Well, this line represents when these different substances will be full in 100 grams of water. And that's a really important statement. So if you look over here, you'll notice it's the concentration in grams per 100 grams of water. So when we think about solubility curves, that's an important idea. And don't forget something about water. 100 grams is the same as 100 milliliters, typically for a sample of water at room temperature. So don't let it throw you. If it says in 100 grams of water or 100 milliliters of water, it's talking about the same thing. It means you can use this graph to read how much can be dissolved. So remember, solubility is the maximum amount that can be dissolved in a given solvent. So these lines represent the saturation point of the solutions at different temperatures in and only in 100 grams of water. So remember, it is tied to that. So really, it's a ratio because of that idea. So how many grams in 100 grams of water at a certain temperature? That's a ratio. When we look at 90 degrees Celsius for something like sodium sulfate Na2SO4, in our pictured graph here, that would be the green line. And at 90 degrees Celsius, so we go to 90, and then we go up to the line, we're right there. It looks like we're right on the line, which would be 40 grams of Na2SO4 in 100 grams of water. So really, when we're looking at this table and looking at these amounts, what we're really looking at is a ratio. Now, if the question says how much we can dissolve in 100, we don't write as a ratio. We just say 40. Now, another mention I want to make about this graph is the significant digits that we can get when we're looking at this type of graph. Now, if you look, it reads to the nearest 10 across the temperature, which means we can estimate to the ones in temperature. And if you look at the y-axis, it reads to the nearest 20, which means I can fairly accurately read to the nearest 10 and then make a good estimate to the nearest ones. So when using this graph, really the way I should write this is 40 decimal point grams of Na2SO4, because I can say it's around 40. Somewhere 39, 40, 41 would be accurate in 100 grams of water. And just to be consistent with this, if we're talking about 40 grams in exactly 100 grams of water, or 40 grams in the same kind of significance, well, we're just going to keep it the same. So we're going to say this is 100 grams of water plus or minus 1. So we say 100 here, we're meaning 3 sig figs. And the 40 in 40 grams of Na2SO4, it's really 2 sig figs, 40 decimal point. So type of question you might answer. And that's what we're going to really look at is a whole series of different types of questions and how you would answer them related to solubility curves. How many grams of sodium nitrate can be dissolved in 100 grams of water at 30 degrees Celsius? Well, it's talking about NaNO3, which is our red line, and it mentions at 30 degrees Celsius. So I go to my temperature, 30, I go up until I hit the red line, and that's where I'm at. Now, if you look at this, I'm just a little bit past the halfway there. Not a lot, but it is a little bit past the halfway. So I know it's going to be a little bit greater than 90. So what I might say is 91 grams of sodium nitrate. That's how much I can dissolve in 100. Now keep in mind, there's got to be some give and take here when we're interpreting this. You might have said 90, somebody else might have said 92, I might have said 91. We're all close to each other, so those would all be valid measurements. So when I ask the type of question, I have to give you a little bit of range for error here that would be acceptable. But I would say it's around 91 grams. Another question, what's the solubility of sodium nitrate at 30 degrees Celsius? Well, it's still sodium nitrate, so we're still talking about the exact same substance. And we just saw 91 grams was what the graph told us. But remember, that's 91 grams in 100 grams of water. When we're talking about solubility, we have to specify how much to be full, the maximum amount that can be dissolved in a given amount of solvent. And in this graph, it's for 100 grams of water. Now, that's an important statement because one of the things you have to watch out for is whenever we're talking about different than 100 grams of water, if that's the case, then we're actually going to use this as a ratio and do the problem like a proportionality, which we'll see in a little bit. Another question. 65 grams of sodium nitrate is dissolved in 100 grams of water at 30 degrees Celsius. So we know we've dissolved 65. Just a second ago, we said we could dissolve up to 91 at that temperature. So what type of solution is it? Well, if we only put in 65 and we can dissolve 91, we're clearly less than saturated. Now let's say I hadn't read or figured out 91 grams yet. So let's go back to the graph. We know at 30 degrees Celsius, so it's the same green line we're written here, but it says we've dissolved 65. So if I look at where 65 is, halfway is 70, so 65 is going to be somewhere in here. Now remember, this would be when I'm full, and I'm clearly below full. So whenever I'm reading the graph and I'm below the line, then we're going to call that unsaturated. If I'm on the line, remember the line represents saturation, so we would call that saturated. Now, one tricky thing you got to be careful of is when you're above the line. So let's say we are here. I throw 120 grams in. Well, I'm above the line, but that's not super saturated. I just threw in too much, and the extra is just going to settle to the bottom. Remember, the only way to make super saturated is to have it all be dissolved, and that typically means heat it up till it's very hot and then slowly cool it off, and it will often remain dissolved even though it shouldn't be. So if you just throw it in there, you're not making a super saturated solution. But if you're above the line and it clearly is all dissolved based upon the wording of the question, yes, you would get a super saturated solution. But in this case, we are below the line. That's clearly unsaturated. Other questions. 80.0 grams of ammonium chloride. So ammonium chloride is the bluish, kind of the lighter blue color. It's added to 100 grams of water at 65 degrees Celsius. How much is undissolved? Well, I added 80 and I'm at 65. So first I need to look at where I'm at. Well, 65 is going to be about here, and 65 and 80 are going to hit at that point right there. So if 80 grams is added at 65 degrees Celsius, how much is undissolved? Well, remember, this is where I'm supposed to be, right at that point. So I'm only supposed to have dissolved some of this 80 grams. Well, when I look at that, it looks to me like it's pretty close to right on that line. So if I put in 80 and I can only dissolve 60, that must mean 80 minus 60, about 20 of it is going to be left undissolved. Remember, that's 20 with two sig figs because it was 80.0 and 60 decimal points. So we got to round to the ones. Well, 20 is already rounded to the ones, but to make that zero count, I need to put a decimal. So the best answer here would be about 20 grams of ammonium chloride. Or I could write it as 2.0 times 10 to the first grams of ammonium chloride. Same thing. But they both show the same number of significant digits and they're the same number, so they're both perfectly acceptable. So this is another type of question. If we're above the line, then we've got more than full. So how much is going to be sitting on the bottom? How much ammonium chloride can be dissolved in 250 grams of water at 65 degrees Celsius? You need to catch something and you need to learn to look for it immediately with these types of questions on the test. We've got 250 grams of water. The graph is only good for 100 grams of water. So if we're interpreting numbers from the graph, they're going to be how much we can dissolve in 100. Now for ammonium chloride at 65 degrees Celsius, that would be right here. 60 grams can be dissolved in 100 grams of water. So the graph tells me what's to the left of my equal sign in my proportionality problem here. So remember, what's on the left, we're always going to get from the graph. Top's going to be the number from the graph that I read, and the bottom's always going to be 100 because that's what the graph is for 100 grams of water. Now, if I know how much can dissolve in 100, it's going to be proportional how much can dissolve in 250. So I set up a simple proportionality. And since I want to find how much ammonium chloride needs to be on the top, just like it was over here. So if this is ammonium chloride, then this has got to be ammonium chloride too. If this is water, then this has got to be the water too. So 60 over 100 is going to equal x over 250. Solve for x. So that's going to be 60 times 250 divided by 100. And because of my 60 decimal point and my 250, which only has two sig figs, my final answer would best be described to two sig figs, and that would round to 150 grams of ammonium chloride. So watch for this. Whenever you see that it's not 100 grams of water, 100% of the time you're going to be doing one of these proportionalities. To the left of the equal, put how many can dissolve in 100, and to the right, put your x in the appropriate spot. If it's asking how much water, x is going to be on the bottom. If it's asking about how much can dissolve, the x is going to be on top. And on the bottom, we're going to put how much water it said we have. And remember, it could be anything. It could be 62.5 grams of water or whatever. It didn't have to be 250. But the proportionality is still going to be the same. So if 60 dissolves in 100, we could find out how much could dissolve in any amount of water just by doing the algebra. Another question. 120 grams of ammonium nitrate is dissolved in 100 grams of water at 7 degrees Celsius. How much should precipitate if the solution is cooled to 50? Well, right away I see 100 grams of water because now that I've talked about it, I always want to look at that first. If it's not 100 grams of water, we're always doing proportionality. In this case, it was, so that means it's going to be a different style of question. So think through what it tells you and what the graph tells you. Now it says 120 grams is dissolved in 100 grams of water at 70. So let's look at where I'm at. Here is my 70, and I dissolved 120 at 7 degrees Celsius, and my substance was sodium nitrate. That's my red. So that means I'm right here. And remember, we're looking at this red line right there. We are just below that red line. So let me draw that a little bit better. If here is my line, there's my 120. I'm just a tiny bit below that line. So that means I have an unsaturated solution with a whole bunch of stuff dissolved in it at 70. Now when I go down to 50, so here's 50, and I'm looking at the red line, I can dissolve a little bit more than 100, not 120. So the difference between my 120, which is what I currently have at the high temperature, and how much I can dissolve at 50 is going to be how much should precipitate out and be sitting on the bottom. Now, when I look at that graph, it looks to me like it's about half of a half. So it's about a quarter of the way up. So I'm going to guess it's around 105. And you may not have exactly that, but you're probably going to be fairly close to it. So 120 decimal point minus 105 is going to be 15 grams of sodium nitrate should be sitting on the bottom. So another subtraction type problem. Another question. 140.0 grams of potassium nitrate is added to 100 grams of water at 30 degrees Celsius. What type of solution? Well, let's take stock. Potassium nitrate, that is the purple looking line here. So we're talking about this line right here. And we're at 30 degrees Celsius and we put in 140. So 30 degrees Celsius is here. 140 is going to be way up there. Well, that's way above the line. So you might be tempted to say, oh, we're above the line. That's supersaturated. But remember, all we did was throw it into the beaker. We can't magically make a supersaturated solution just because we want to. It has to all be dissolved. And if I just add more than can dissolve, the rest of it's just going to be sitting on the bottom. So this would be a saturated solution. Remember, you're above the line, you're saturated, unless it specifies it was all dissolved. And just throwing it in there is not going to make it all dissolve. So this will be a saturated solution. Be careful. There's almost a 100% chance I'm going to ask one of these on the test related to this. And that basically ends our notes over reading and using solubility curves.